Another question that seems simple on the surface but can actually be pretty complex, and that is, what is the iteration protocol in Python? And what by that I mean, or by that people asking this question mean, how does a for loop really work? And why do some objects work in for loops and others don't? So we all know that I can say for one item in ABCD, print one item. Oops. Print one item. And that makes sense. Okay, right? And we can sort of intuitively understand, okay, the for loop is iterating over the string. We're getting one item at a time. Well, let's say for one item in open Etsy password. Print one item. Now, I've used exactly the same for loop, but in this case, I got back one character at a time. Got one character at a time. Not that there's really a character data type in Python, but I won't tell anyone. And here I got one, I got one line at a time. So what's going on? How can the same for loop, without any use of indexes, without any obvious differences there, how can it give me such different types of data and different responses from different objects? And the answer is basically that the iteration protocol in Python is a very generic sort of, it's a protocol, it's an API. And the for loop does very little work, actually. Most of the work is being done by the object itself. So here's what happens. When I have a for loop, for turns to this string, or to this file object, or to a list, or a dictionary, anything. For turns to the object and says, are you iterable? The first question to ask is the object iterable? And the second question then is, basically, if you're iterable, then give me your next item. And this repeats and repeats and repeats, repeat to, until we get a stop iteration exception. That's the protocol. That's it. And it seems so simple, and it seems so simple-minded, even you might say, that it's not really that sophisticated. It's not using indexes. It can't let you go skip forward and skip backwards and rewind and everything. This is the protocol. So when Python wants to find out is something iterable, it can use the iter function. So we can say s equals abcd, and I say iter on s. And iter on s is not something we're going to normally run ourselves. In fact, if you're running iter, probably you're doing something a little weird or wrong or advanced. But if you say iter on s, you're going to get back the iterator object that knows how to return the next thing and the next thing and the next thing. And sure enough, here we get a string iterator. Well, if I say my list equals 10, 20, 30, 40, now I'm going to say iter on my list, and we're going to get back a list iterator. So each of these iterator objects basically are there so that we can then grab the next thing and the next thing and the next thing until we get to the end. So if I say I equals iter of s, and by the way, each time you run iter, you're going to get a new iterator object, even if it's on the same original object. Then I say next on I, and I get the first thing, I'm going to get A. Next on I, I'm going to get B. And then next on I, I'm going to get C, unless something really terrible happens, right? And then next on I, I'm going to get D. And then what happens after that? Well, I said already, we're going to get a stop iteration exception. And so what you can imagine is that the for loop is actually very, very stupid. The for loop is basically saying it's running iter. If iter works, if iter gives it a value back and doesn't give it an exception saying unsupported type, like a type error that's not iterable, then we're going to get back this iterator, and we can just call next and next and next and next again and again and again until we get stop iteration. So you can imagine, this is not the way it's written, but you can imagine def for. This is not going to work, right? We'll say my for, just so we don't get really crazy on data. And this is the way it sort of kind of works. So it'll say here, I equals iter of data. And then we can say here, while true. And we'll say here, try, and it'll be return of next I. And then we say, except stop iteration, break. Now, there's a problem with this implementation. The problem is that return means that the function will return right away. So this is not really how for works. But you can imagine this is how a for loop works. By the way, this is why a language must have a while loop. It doesn't really need to have a for loop. You can implement for in terms of while. So how is this useful? Well, first of all, it's useful in understanding some error messages we might get. Like if I say here for I in 10, print I, this is going to break. It's going to break right away. And the reason it's going to break right away is that 4 turns to 10 and says, are you iterable? It runs iter on it. And the answer is no. Now again, you shouldn't be running iter, you shouldn't be running next, but this is what's happening behind the scenes. And both of these functions aren't built in, so they're available to us if we really want. And sure enough, we get int object is not iterable. Okay. But let's say something is iterable, right? Then it can return all sorts of different things. So a string returns characters, lists and tuples and sets return their elements, dictionaries return their keys, files return their return their lines, and you on your own objects, on your own classes, can also implement this iteration protocol if you really want to. So you can say here class, right? And let's do this. Let's say here double iter. And there's a kind of silly iterator we can do here, where it's going to return everything twice. So if I give it ABC, it'll return A, then B, then B, then C, then C. Okay, not so exciting. Right? Def init self data. Whoops. Let's do this here. Self. Okay. And I guess we need to get data, right? Yeah, that always helps. And this data is going to have to be iterable. So we'll say here self data equals data. Say here self index equals. So far, so good. So how is this object going to respond to the iter function? So far, it's not. So instead, we have to say def under iter self. I'm going to do the really simplest version of this, so I'm just going to say return self. There are other ways to write an iterator in Python, and I'll explain the problems with this way in just a moment, but like this is a simple way to do it. And I can say def next self. Notice that neither iter nor next take any additional arguments beyond self. It sort of has to be in the state of our object. And then I can say, okay, dunder next, what am I going to do? Well, I can say here, if self index is greater than len of self data, then what I'm going to do is I'm going to say here, raise stop iteration. That's going to be our stop. Otherwise, what am I going to do? I'm going to say value equals self data, self index. And I can say return, well, we have to say self index plus equal 1. And then return value. And now if I say here, and by the way, I realize it's not really doing what I said it would do. Give me a moment. If I say here, D equals a double iter of ABC, and we say here, for one item in D, print one item. What are we going to get? We're going to get A, then B, then C. And why are we getting that? Oh, and then I guess I have to do greater than equals. Good old off by 1 errors. Good thing I've done this hundreds of times, right? There we go. Much better, much better. Now, I promised that we were going to do everything twice. So how can we do that? Well, one way that we can do it, one way is we could basically double the length, right? So I could say here, if it's greater than or equal to the len times 2. Yeah, but then what am I going to do? Then what I have to do is I have to say here, self-index divided by 2. And I can even say int of self-index divided by 2. And that should do it for us. AA, BB, CC. Haha, it wins. So what you see is this is a way for us to give different functionality, sort of wrap different functionality that still works within this iteration protocol. So any class that wants to implement the iteration protocol must have an iter method and must have a next method. This is, again, the simple-minded way to do it. And the problem with this is that basically our iterator, we can only iterate over it once. After we do that, then we're sort of stuck. So if I say here, for example, print 1, 1, 1, 1, 1. And then I'm going to do it a second time. I'm going to say here, print 2, 2, 2, 2, 2, 2. And then, right, then I'm going to say the for one item in D, print one item. And the problem is basically that, fine, we'll do 2, 2, 2, 2, 2. But then after that, 4 turns to D and says, are you iterable? The answer is yes. And then it says, okay, give me your next. But it's already gotten to the end. Self.index is already at the end. So the typical way you're going to do that is with a separate iterator object that's above and beyond sort of this one. So instead of having all the methods defined in double iter, what you can do is you can define a double iter iterator. Right? We can call that quad iter now. Class double iter iterator. And then what's going to happen there is it's going to have next defined on it. So what I can do is I can move this down here. Or move this from down here to up here, I should say. And then what I'm going to do is not return self, but return a double iterator of self data. And then I can get rid of self index from here. Well, actually, let's copy init from there to there. And then we'll have that there. All is good. And I just get rid of this from here. And what's the advantage here? There are multiple advantages. One is that now I can iterate over my double iter instances multiple times. I don't get to the end. Although you might want that, right? Files, once you get to the end, you're at the end. Another thing is that if I have any other functionality in my double iter class, which doesn't sound like I'm going to, then I can separate out the iteration functionality from the main class functionality. So either way, this is not a bad way to do things. And now if I run my double iter again, iterate over it, I'll get, ABC, ABC, and it works just fine. This is, by the way, something we can see all the time. Before, you might remember that we saw there were list iterators, string iterators, and so forth. This is the reason. They're using a separate class so that you can do iterations either in parallel at the same time or just not sort of have one collide with the other. The iteration protocol is one of the most important protocols in all of Python. It's worth knowing how to implement it. There are other ways to do it too, but this is a good place to stop and summarize what we've done. All right, onward.